we are monitoring a live situation right now. It's actually a major collision in space, so let me tell you about it. This is a live image on your screen. NASA is about to intentionally crash a spacecraft into an asteroid, and they're going to do it right here on live television. And when literally we're in the last minute. The asteroid named Dimorphos you're looking at on your screen. The spacecraft is NASA's Double Asteroid Redirection Test Spacecraft. That's a lot. Call it DART. Now, Dimorphos poses no threat to Earth tonight, but the goal for NASA is to see if they can push the asteroid off course. So it's something they could do in the future to prevent Earth from Armageddon. It is the first time NASA is attempting a test like this. So let's go straight to Kristen Fisher at Johns Hopkins Applied Physics Lab. She's in Maryland, where Mission Control is. Colonel Layton also is with me because he's worked closely with NASA and has a good understanding here of this situation. So, Kristen, we've got this live image on the screen. You're there in the control room. This is a first, an unprecedented event. Tell us what we're looking at.
Well, Aaron, we are now exactly 2 minutes and 58 seconds to impact. And what you're seeing right now on your screen is all live images from a camera that is mounted on the DART spacecraft. And for a mission this complicated and consequential, what's about to happen is actually quite simple. NASA is going to take this multi-million-dollar spacecraft and just slam it into an asteroid. Not the asteroid, the biggest one right in front of you on your screen. That big asteroid at the center of your screen, just to the left, that is ДИДМОS. That is what the DART spacecraft has been targeting for the better part of 10 months while it's been in space. Its target is that smaller asteroid, Dimorphos. And so this spacecraft is traveling at a speed of 4 miles per second, not per hour, 4 miles per second. That's about 14,000 miles per hour. And Aaron, it is going to, in 2 minutes, slam into that smaller asteroid on the right, Dimorphos. You're going to watch as it fills your screen. And then when it hits, it's just going to go black. Complete loss of signal. One of the only times that you're going to see a NASA mission control room hopefully cheer at the destruction of a spacecraft and the loss of signal, Aaron.
Right. To have something go to black, the last thing you would want on any ordinary mission, but this is no ordinary mission, Colonel. So, Kristen explaining, so we're looking at the smaller dot there. That is Dimorphos. I guess these two asteroids sort of go together. Dimorphos is the one it's going to slam into. It's about the size, I understand, Colonel, of Egypt's Great Pyramid. The spacecraft is equivalent to the size of a refrigerator, and you're in the vast vacuum of space here. How is NASA, I mean, how amazing is it that NASA could pull this off?
Well, this is incredibly amazing. This is really the first time, Aaron, that we are using things that we've talked about in science fiction, things that we see in movies and in the TV series that is really designed to protect the environment and the planet itself. You go back to the time of the dinosaurs, and the theory is that the dinosaurs were made extinct because of an asteroid or a series of asteroids hitting the Earth. There was a case in Russia in the early late 19th century, early 20th century, where we actually had an asteroid hit Siberia that resulted in a lot of destruction of territory there. Luckily, not very populated territory, but still the danger is definitely there. And it's something that even though the probability is low, it's one of those low probability, high impact things that could happen. So with this experiment, we're looking at NASA potentially being able to protect our planet from asteroids of the future.
And we're watching here as the spacecraft DART approaches Dimorphos. You can see it getting closer and closer. We're here just in the final few seconds. 14,000 miles an hour is what you're watching. The camera that we're watching is traveling 14,000 miles an hour on DART, the spacecraft, the refrigerator-sized spacecraft that's going to slam into Dimorphos here. We're just literally a few seconds away. So I understand, Kristen, as it gets closer, we're just going to see it get closer and closer, and then literally, I kind of hear a lot of talking behind you. We're going to just see an explosion, then go to black.
It's amazing, guys. Oh my God.
That's right, Aaron. It's going to happen any second now, and we're going to see big cheers go up in the mission control, which is right
excited.
here. You've just got some other folks here cheering, but this is it, the moment. DART hitting the Dimorphos asteroid. Right now, wow, look at the detail that you can see.
It is amazing. It looks like a...
So those are rocks on the surface of Dimorphos of some kind. Big cheers going up here inside the Johns Hopkins Applied Physics Laboratory. Aaron, you just think about how much time and energy the people in this room have how much time and effort they put into this being a success. And there, I think you can see the crowd cheering down in Mission Control. Probably the only time that you're going to cheer for a loss of a spacecraft, Aaron.
And we have impact, a giant leap for humanity in the name of planetary defense.
In the name of planetary defense. And now, okay, pretty amazing to see it. I mean, this sounds like the room, obviously celebration in that room. I mean, talk about threading a needle, Kristen. I mean, you just said, you're talking about that they just sent from Earth an object the size of a refrigerator into an object the size of the Great Pyramid in the middle of space at 14,000 miles an hour, and they hit it.
It's unbelievable. So now, Aaron, the next big challenge. NASA has completed its first big objective. They've proven that they can do this. They've proven that they can take this spacecraft and slam it into an asteroid. Now the big question is, were they able to successfully move this asteroid off its current orbit? They're not trying to move it by a lot. This asteroid is not going to blow into a million pieces like you saw in Armageddon. All they're trying to do, Aaron, is move it just slightly off its orbit so that if this were to happen in the future, where there were an asteroid that was potentially going to wipe out all of life as we know it on planet Earth, could they do this far enough in advance and knock this potentially killer asteroid off orbit and save the planet? I mean, that's truly the technology that they are testing here. And so it's going to take a few weeks before we know if they've successfully completed that objective. They do it by using ground-based telescopes that can actually see the orbit of that asteroid, see if they were able to push it off course. But tonight, I mean, you see these celebrations going on in Mission Control. Just a big moment for this team, proving that NASA's first planetary defense test mission is at least 50% a big success here.
And Colonel, just to be clear here, if you had an asteroid about 5 times bigger than this one, it could destroy civilization as we know it, right? I mean, so the what's at stake here is incredibly serious if this works, right, in terms of preserving civilization.
Absolutely, Aaron. And the key thing here to remember is that these types of asteroids, can come in various sizes. They can pose various types of threats to the planet. And by doing this test, what NASA has been able to do is they've been able to show, as we've seen just tonight, they've been able to show that they can actually do something that potentially can alter the track, as Kristen was mentioning, the orbit of these asteroids. And if they can do that, if they get the angles right, if they get everything in to make it work, that could potentially save life as we know it.
Yeah, and good for them to have a victory after all these delays that have been happening on Artemis. All right, thank you both very much. I appreciate it.